We can also write tests to check that two object references are equal, that is, they point to the same object. For example, one test that we could write for our enemy factory is that when we create two instances using the factory, those instances should be separate objects. So we'll go and create a new test called create separate instances. We'll go and call the create method twice here, and we'll get two enemies back, enemy1 and enemy2. What we want to do here is to check that these two enemies are in fact separate object references, or in other words, they're not the same enemy. To do this, we can use the assert.notSame method. This method takes two parameters and verifies that these two objects are not the same instance. So here we specify our first instance, enemy1, and our second instance, enemy2. Let's run this test. And the test passes because these are in fact two separate instances. There's also a complementary assert.same method, and this will check that the two instances are the same. If we run the test now, the test will fail because it's expecting enemy1 and enemy2 to be the same reference, whereas they're actually different references. Let's just fix this up by changing this back to assert.notSame. And now the test should pass, which it does. During test execution, if an exception is thrown, then the test will automatically fail. But sometimes we want to check that our code is actually throwing exceptions at the correct times. So we're going to go and write a test now to check that when we call the create method of our enemy factory, that if the supplied name is null, then we expect an argument null exception to be thrown. So let's go and add a new test, and we'll call this test not allow null name. We'll create our instance of the enemy factory, and then we're going to go and call the create method of the enemy factory, passing a null for the name. So in our test code here, we want to say that we're actually expecting an exception in this instance, and in fact, if we don't get an exception thrown, then the test will fail. To expect an exception, we can use the assert throws method. Notice here we can specify a generic type, and this is the type of exception that we expect to be thrown. In our case, in this enemy factory, we're expecting an argument null exception. So we can specify argument null exception as the generic type parameter. As an argument to this assert throws method, we need to specify the code that's going to be executed that will cause the argument null exception to be thrown. To do this, we can use a lambda expression, and what we're going to say is we're going to call the enemy factory's create method, and we're going to provide a null name. This should cause the argument null exception to be thrown, and because we're expecting this exception using assert.throws, this test should pass. So let's build this, and we'll head down to Test Explorer and run this new test. And we can see our test passes. If we were to go and comment out this line and run the test again, the test will fail because we're expecting an exception and no exception will be thrown. So let's just undo that. And once again, the test will pass. We can get more specific and supply the parameter name. So let's comment out this line. And we'll paste in this version. Notice here, we've got this additional parameter, and this is the name of the argument that we're expecting to cause the argument null exception. So once again, let's run this. And the test passes. If we were to change this to the other parameter, the isBoss parameter, and run the test again, this time the test will fail because the argument null exception that's been thrown contains the parameter name name rather than the expected parameter name isBoss. So let's just fix this and check the test still passes, which it does. If we head back to the enemy factory, notice here we're checking the isBoss parameter. If we specify that we want to create a boss enemy, we're going to perform this additional validation and check if it's a valid boss name. If it's not a valid boss name, then we're going to throw this new enemy creation exception. And if we just scroll down, we can see the isValidBossName method here is checking that the boss name ends with either king or queen. So all bosses have to be a king or queen. Let's write a test to check that this enemy creation exception is thrown. We'll head back to our test class. We'll write a new test method called onlyAllowKing or Queen Boss Enemies. We'll create our enemy factory, and then we're going to use the assert.throws method once again. We can see here that we're expecting the enemy creation exception to be thrown when we call the create method, and we pass true to say that we want to create a boss enemy. But notice here the name doesn't end with king or queen, so we should get the enemy creation exception thrown. Notice here that I'm also capturing the thrown exception into this variable ex. This means we can make further asserts against the thrown exception. If no exception is thrown, then the test will fail. Let's add an additional assert here to check that the requested enemy name property of the thrown enemy creation exception object is set to zombie. Let's build this, and we'll head to Test Explorer and run this new test. And the test passes. In addition to asserting that during execution an exception should be thrown, we can also assert that events are raised. If we have a look at our player character here, and if I just scroll down, notice we've got this event called player slept. If we scroll down to the sleep method, we can see that as part of this sleep method, we're calling the onPlayerSlept method. And if we scroll down to this method, we're going to raise the player slept event. So let's go and write a test to check that when we call the sleep method, the player slept event is raised. We'll go to our player character test class, and we'll scroll down to the bottom. And we'll add a new test called raise_slept_event. We'll create our player character instance, and then we're going to use the assert_raises method. We can specify the type of the event arguments we're going to expect. In our case, we're just going to specify event args. And there's a number of arguments we need to provide here. The first argument is an action which attaches to the event. So here we're going to use a lambda expression, and we're going to attach to the player slept event. The second parameter is the code to detach from the event handler. Once again, we can use a lambda expression here, but this time we're specifying -= to detach from the event. And the third parameter is the action that should cause this event to be raised. In our case, it's when we call the player character's sleep method. So now if the sleep method is called and the player slept event is raised, this test will pass, but if it's not raised, this test will fail. Let's build this. And we'll head back to our player character tests. And we'll scroll down to our newly added test, should raise slept event, and we'll run this test. And we can see the test passes. If we head to our player character, and we comment out this line, if we run the test again, the test should fail, because we're no longer raising the event. And we can see here the test failed. So let's just fix that up. And the test should now pass. If the class we're testing implements iNotifyPropertyChanged, and we can see our player character here does implement this interface, we can use a special version of event assert to check specifically for the property changed event. So let's head back to our test class, and we'll add a new test, this time called raise_property_changed_event. Notice this time we're not using assert.raises, we're instead using assert.propertyChanged. There's 3 arguments we need to supply to this method. The first is the object that's going to raise the property changed event. In our case, this is the instance of our player character. The second argument is the name of the property for which the change notification should be raised. And the third argument here is the action that should cause the property changed event to fire. In this case, it's the take damage method of the player character. And if we have a look at this method, we can see that we're updating the health property. And if we have a look at the health property, we can see that when we set this property, we're going to raise the property changed event. So let's build this, and we'll head to our new test. We'll run this test, and the test passes. If we go and comment out this line here, the test will no longer pass because we're no longer raising the property changed event, and we can see the test has failed. Let's just fix this up and check that all of our tests still pass. And we can see now all of the tests are passing. So that brings us to the end of this module. In this module we covered a lot of ground. We started off by getting a high-level overview of asserts, such as the considerations around how many asserts we might have in an individual test method. We then jumped into Visual Studio and we started to learn about the different assert capabilities of xUnit.net. We started off by seeing how we can assert against Boolean values using assert.true and assert.false. We learned a number of different ways we can assert against string values, including assert.startsWith. We saw that we can assert against numeric values, including checking that a value is in an expected range. And we learned how we can assert against null values. We saw a number of ways we can assert against collections of objects, including assert.contains, and also how we can check that objects are of an expected type. We can also assert that two references point to the same instance, or in fact different instances, using the assert.same and assert.notsame methods. And we saw how we can assert that our code throws the correct exceptions. We also saw how we can check that our code raises the correct events, such as using the assert.raises method. Join me in the next module when we'll learn some powerful ways of taking control of how our tests are executed, including how we can categorize tests and run tests in specific categories, and also how we can output test messages during test execution.